Alright guys, so 2-3 is going to be linear equations. Now a linear equation is a first order differential equation in the form. So again, this is just a sub 1 x, a function of x times dy dx, right? Your first derivative, first order, plus some other function of x times y, and then it'll equal a function of x. So only y's you're going to see, right, is the dy dx and y here. Everything else is going to be a function of x times one of those and then equal to a function of x. Okay, so that's the form you have. Now, standard form, okay, for linear is dy dx. So again, we're going to make sure when we start to solve that this function of x is divided out, so you only see like a 1 times the dy dx. Okay, plus the notation is p of x, and you'll see why in a second, but again it really just means a function of x equals a function of x times y and then equals another function of x. Okay, so an example, right, would be dy dx plus 2xy equals 0, or you could have dy dx equals y plus 5. All right, I know this doesn't look like that order, but you could rearrange it, right? Dy dx minus y equals 5, and then you have it in that order. And remember, constants are, so like 0 and 5 are still functions of x. Okay, now with these two, okay, these two you can separate and integrate. Also, they are linear, what we're doing today. Okay, so here, just to show you how you would separate. So usually separate and integrate is what people prefer, right? But you could see this one, you could just write it dy divided by y equals negative dx over 2x. Okay, my bad. No. Negative 2x times dx. Thanks. And this one, right, you could just break it up as dy over y plus 5 equals dx, and you could see how you could separate and integrate. But these are also considered linear, right, because they're in the form where, you know, you have your derivative plus a function of x times y equal to a function of x in both of those situations. Now, something that is just linear, okay, would be, and we're going to solve this, I'm going to solve this for you in one of the examples. All right, this is only linear, meaning, right, if you can't separate and integrate. Okay, so let's start with a basic differential. Actually, before we do that, let's do this. Okay, so I'm going to work through a little process. Let's find the derivative of xy, right, with respect to x. So here we know from implicit differentiation, right, product rule, derivative of x, all right, so I'll write it out for you, times y plus x, and then the derivative of y with respect to x. So here, derivative of x with respect to x is just 1. This gives us y plus x. Derivative of y would just be 1, but with respect to x, it's going to wind up being dy dx. Okay, so you could see where that linear is starting to form here. Okay, so let's take the differential equation, y plus x dy dx equal to, let's just make it 0 for now. Okay, and my question is, right, obviously we know that this matches what I did above just because I just did the derivative of x times y here. So I know that's what my function y should look like, right? My solution to this should look like. But how do we get there? Okay, so let's put it in standard form. So I'm going to divide everything by x and just rearrange it so it's in standard form. And, you know, we could see, right, here is our p of x. So that is going to be one of the most important things here, right? Because you'll see where I'm going with this. If I know that this is p of x, okay, and I want to say to myself, think of what we did up here with product rule, okay? And what I could think of is because, right? Because what's the derivative of y, dy dx? If I could put, I know I'm using highlighters here, if I could put a function here whose derivative is this one, then I have that product rule. Now, if you think about it, okay, what function has the same derivative as itself? What is the function that has the same derivative as itself? Okay, and we call that e to the x, that exponential function. And we use this is called the integrating factor. Okay, in your book, they use that mu notation of x. So again, a function of x, and it's going to be e, the integral of p of x. So this, right, p of x dx, and that's your integrating factor. So in this specific equation, right, if we're trying to find that factor, I'm going to do e to the 1 over x dx, right, which is e to the ln. And in here, you don't need the absolute value of x. It'll just go away, and think of your inverse properties. E to the ln is x. Okay, now with that, what I want to do is multiply everything by x. So I'm going to take this standard form notation and multiply everything by x. Okay, integrating factor. You want to multiply everything in standard form by that factor. Okay, so here it's x. So I get dy dx plus y equals 0. Now, all right, you could see, right, that this is just product rule of xy, okay? And over here will be 0. So now what we could do is once we get to this step, let's integrate. And you can see why I want to integrate here. So an integral, right, what happens if you're doing an integral of a derivative? It just cancels out and you're left with the integrand itself. Okay, and this is the antiderivative of a 0 is just c, right? And, you know, basically we went from what we started with up here, right, xy, and we came down to that same conclusion down here, and you can see where that's going with. Okay, and the key steps, okay, so when you're doing this, the key steps, right, 1, put in standard form, okay, which is going to be dy over dx equal to, plus p of x y equal to some function of x, right? Okay, find integrating factor. Which is going to be mu of x e to the integral of our p of x function dx. And then 3, multiply every term in standard form by p of x, right? Oh, my bad, not p of x, by the integrating factor, mu, right? And then what you will notice is that you'll have, you know, the integral of the derivative of that integrating factor times y equal to some, let's say, some other function. I'm just going to change it to g of x, and then you go from there where you have that mu of x times y is going to equal that integral on the right side, okay? And then just integrate right side and solve. Okay? All right, so let me show you a couple examples here. Okay, so we'll show you first example, right? I'm going to have dy dx minus 3y equals 0. Okay, and you could solve this by separate and integrate as well. I'm just going to show you the linear process. So first, I'm going to, is it in standard form? It is in standard form already. Okay, second, what is p of x? Right, so that's negative 3. So my mu of x is going to be e to the negative 3 dx. Mu equals e to the negative 3x, okay? Don't worry about the plus c, okay? Third step, let's multiply everything by that factor. 3 negative e to the negative 3x dy dx minus 3 e to the negative 3x y equals 0. Now, if you notice, what is the derivative of y? Dy dx. What's the derivative of e to the 3x? Negative 3 e to the 3x. And there you could see your product rule right there, okay? This is just the derivative of that mu that we had and y, right? So e to the negative 3x and y. We're going to take the integral of that. That's step 4. Okay, and the integral of the right side, and we will just wind up being this notation here. Now, if we're solving for y, you're dividing everything by e to the negative 3x, e to the negative 3x, and I could just rewrite that as c e to the positive 3x, and there is my general solution for the differential that we started with. Okay, so you start here, your solution is going to be here. All right. Okay, next part. All right, example 2. So let's do similar, and this way I could go through this pretty quick, but what if it's equal on the opposite side to something other than 0? All right, so in this case, we already know standard form. We're in standard form. Okay, p of x, right? Everything's going to be pretty much the same, right? Where we'll have mu to be e to the negative 3x, all right? Just taking that from last time. If we multiply everything by that, right, you'll get negative e to the 3x. dy over dx minus 3 e to the negative 3xy, and on this side now, right, we'll have it look like that. This doesn't change, right? Again, derivative of, if you notice, y is dy dx, derivative of e to the negative 3x is negative 3 to the negative 3x, so that's our product rule. And then here we have the right side. So now I want to integrate with respect to x, both sides, and when you do that, the left side is always left with that mu value times y, okay, times y, mu value times y. Over here, so antiderivative, so it's 6 over negative 3 equals, idiot. Okay, e to the negative 3x plus c, right? And we could clean it up, negative 2 e to the negative 3x plus c. And then again, I'm dividing everything by e to the negative 3x, giving me negative 2 plus c e to the positive 3x. All right, so we start with this differential, and that's my solution, a general solution, because we don't have an initial value with that. All right. Now, let's try one that's not in standard form. Example 3. I got, let's do an x dy dx minus 4y equals x to the 6th e to the x. Okay, so here we want to put in standard form. So what I'm going to do is divide by x. So I get dy dx minus 4 over x y equals x to the 5th e to the x. Okay. Now, p of x is that negative 4 over x. So mu e, I'm going to kick out the negative 4, 1 over x dx. That's going to give me e to the negative 4 ln x. Okay, don't worry about that absolute value. Some properties here. You could bring, when you're dealing with logarithms, bring that coefficient as an exponent, and then you could see the e and the ln cancel out. They're inverses, and you get x to the negative 4. Okay, I'm going to multiply everything by x to the negative 4. Okay, so now here you could see that's the derivative of, right? Let's talk about it again. We already know derivative of y is dy dx, okay? And then the derivative of x to the negative 4 is that negative 4x to the negative 5. So we get x to the negative 4 y equals x e to the x. So let's take the integral with respect to x. Left side's very easy now, cancels out. Now, let's talk about this, okay? Actually, let's bring this down so I can show you this. Okay, cool. All right, so this is by parts. Integration by parts. All right, so here, I'm going to show you the chart method. When you're doing this, your u is always the one that you want to kind of eliminate the quickest. E to the x never eliminates. All right, you just, what's your derivative, what's your antiderivative? It just keeps repeating, okay? And this is dv. So x is my u, e to the x is dv. And so on the u side, you're taking derivatives until you get to 0. Till 0, so derive till 0. On this side, antiderivative, right, until it matches with that 0. Match. With 0. Okay. Now, let's use blue. Okay, here, and it starts with plus, minus, okay? So what I'm going to have as my antiderivative there, I don't need that. Okay, so plus, it'll be x e to the x, and then minus e to the x, and then don't forget your plus c. You could always go by parts with the formula notation. I showed that earlier, I showed that in other slides as well. Okay, and there is our solution. But if I'm solving for y, okay, I'm going to divide everything by x to the negative 4. Not negative x to the negative 4. just x to the negative 4. And so what I wind up getting is x to the 5th, e to the x minus x to the 4th, e to the x, and then plus x to the 4th, c x to the 4th, c x to the 4th, right? And that is going to be my solution, general solution that we have, okay? So you start with differential, finish with a solution. Okay, next part. Here we go. What example was that? 3. So here, example 4. Okay, example 4, let's do this. X squared minus 9 dy over dx plus xy equals 0. All right, so let's go standard form. Is going to be dy dx plus x over x squared minus 9y equals 0. All right, so our p of x squared minus 9, our mu is going to be e to that x squared minus 9 dx, right? And here we need to do a u sub. So I'm going to go over u sub with you guys. All right, so u substitution, my u is going to be x squared minus 9, my du 2x dx, right? So here I'll have du over 2 is going to equal x dx, right? So you can see as I rewrite that x dx portion will be right there, and I can do that substitution with it. So I'll have e, kick out the 1/2, and then we have 1 over u du, which we know is going to be e to the 1/2 ln u, right? And again, you could write it as e to the ln square root of u, which is just going to be square root of u, and my u, so my mu of x is going to equal square root, plug back what you made u, and then you have that factor there, okay? So multiply everything by that factor. So I'll have x squared minus 9 dy dx plus x squared minus 9, and then x squared minus square root of x squared minus 9 times y equals 0. Now what I wouldn't do, don't worry about multiplying this together and simplifying, because the main thing is, what's your derivative of x squared, square root of x squared minus 9? There it is, okay? And what's your derivative of y? There it is, dy dx, okay? So everything is already there. You just have to put this in product rule. So you have y square root of x squared minus 9 equal to 0. Let's integrate. This just canceled, equal to c. So we get a general form of c divided by the square root of x squared minus 9. Done. Okay, and then let's just do one initial value problem. So here I'm going to have that equation that I said we would go over in the beginning, and my initial value is going to be y of 0 is 4. Okay, so we're already in standard form, right? Standard form, check. All right, P of x is a nice and easy one, is 1. So the mu is going to be e to the 1 dx, right? And so I'll just get e to the x. Let's multiply everything by e to the x. Okay, here I get that product rule. If you notice, I know I keep doing this, derivative of y, dy dx, derivative of e to the x, e to the x. So you can see that's our product rule, x e to the x. Let's integrate with respect to x. Okay, here we already got it. Here we did earlier, right? This is a by parts. Look, it's the same thing I did earlier, by parts. Don't forget your plus c, and then divide everything by e to the x. Okay. Initial value problem, we have to find that c, right? So 4 equals 0 minus 1 plus e to the c e to the 0. So I get 4 equals negative 1 plus c. C is 5. And just plug back in. So now we got a particular solution for this initial value question. And there is my solution for that initial value problem. All right, and that's linear. I'll try to do more examples later in the week. Again, if you have any questions, just email me, and I will continue to try to clarify things. I hope I'm doing a decent job, but if you have any questions, don't hesitate to ask. All right, thank you.